Hello students, I am Limbachia welcomes you all on my YouTube channel. Dear students, in this video lecture, we will solve the example number 1.4. Dear students, the definition of example 1.4 is given on your screen. So let's just understand what is given, and based on that given parameter, we will solve the problem. So definition states that a charged metallic sphere A is suspended by a nylon thread. So dear students, you can see in figure 1.4a, this is the metallic sphere A which is suspended by a nylon thread. Then another charged metallic sphere B held by an insulating handle is brought close to A such that the distance between their centers is 10 centimeters. So look at that. uh, Another charged metallic sphere B is brought closer to the metallic sphere A such that their distance are 10 centimeter apart. Right? Now, as shown in figure 1.4a, the resulting repulsion of A is noted, for example, by shining a beam of light and measuring the deflection of its shadow on the screen. Sphere A and B are touched by uncharged sphere C and D respectively. After then, first what we have to calculate? We have to calculate the attractive force between these two. Okay. Now, dear students, another uncharged sphere C and D, which is made up with same material and same dimension, when touched to metallic sphere A and metallic sphere B, what will happen? We know that when there is one charged body and when there is an uncharged body, when we touch charged body and uncharged body, what will happen? Q charge will move from charged body to uncharged body. Fine. So here in this case, what will happen? Charge will move from sphere A to sphere C, same sphere B to sphere D. Now, as shown in figure 1.4b, C and D are then removed and B is brought A closer to A to a distance of 5 centimeter. Now, after uh, making contact with this particular uncharged sphere, that B charged sphere brought closer to A, that its distance, distance between the center of them, that two sphere, will be 5 centimeter now. So half of the previous distance now between their centers, as shown in figure 1.4c. What is expected repulsion of A on the basis of Coulomb's law? So here we have to find out the F dash. First we will find out Fe, then we will touch that sphere A and sphere B with uncharged sphere C and D, and then we will brought closer this sphere B to sphere A, which is 5 centimeter apart from each other, and then we will find the new attractive. So hope you understand the definition. In physics, if you understand the definition well, then you can have the better understanding that how can you solve this problem. Fine. So understanding the definition is very important in problem solving in physics. Fine. Now, so what we have to do is, let's complete the definition first. Sphere A and C and sphere B and D have identical sizes. Ignore the size of A and B in comparison to the separation between their centers. So, dear students, first, as I told you, I have to find out the attractive force, or a repulsive, sorry, in this case, repulsive force, because both are positively charged. So, here in this case, we have to find out first an repulsive force between sphere A and sphere B. So let's assume, first we have to assume that, assuming, why we have to assume? We have to assume the charges on sphere A and B. So assuming charge Q on A and q dash on b. So what I assumed is the charge which is on sphere A is q and charge on sphere B is q dash. Based on these charges, I can find the repulsive force. So dear students, then I can write the repulsive force between A and B is F dash if then sorry let me take it as a F. So if is F, then F can be found, then F is equal to A q dash divided by r square. So dear students, here r square is given 10 centimeter. Can I write like this? K q dash divided by 10 into 10 raised to minus 2, because we have to convert into the meter square. Give it equation number 1. So this is the first case. Now what we have to do is we have to touch a uncharged sphere C to A and uncharged sphere D to B as shown in figure 1.4b. Look at that. So suppose we have assumed that the charge on sphere A is Q and charge on sphere B is Q dash. Then dear students, what will happen if we connect, if we touch, if we make a contact of uncharged sphere C and D, then the charge on sphere A and charge on sphere B will divide. It means half of the charge will transfer from A to C and half of the charge will transfer from B to D. Why? Because the dimension of the sphere are same, as well as the material which these two spheres are made up with are also same. So if material is same, dimension is same, then the charge will divide equally. So half of the charge will transfer from A to C and half of the charge will transfer from B to D. So it means the new charge will become Q by 2 and here it will come Q by 2. The same, the new charge will become Q dash by 2 here on Q by 2, Q dash by 2. Fine. Then what definition states? We will remove C and D and B will bring closer to the A at 5 centimeter apart. So now we have to find out the new repulsive force. So can I write like this? After making contact of C to A and D to B sphere, the new charge on A is Q by 2 and B is Q dash by 2. You get the point? So the new charge on A will be, in this case, dear students, Q by 2 and here Q dash by 2. So now we can find the repulsive force very easily with the help of these two charges. So therefore the new repulsive force between A and B are is, let me take it as a F dash, is F dash. Then what I can write about F dash? F dash is equal to K Q by 2 Q dash by 2 divided by, now what is the distance between them? Look at that, 5 centimeter, which is half of the previous case. So can I write this as a R dash, this as a R dash, and what is R dash? R by 2, because it is 5. In previous case it is 10. So 10 divided by 2, it means 5. So I can write R dash as R by 2. So from this I can write R dash square. So can I write like this now? k q by 2 q dash by 2 r by 2 square. Instead of writing r dash, I have substituted r by 2. So now I just have to do the simplification. Then f dash will be k q by 2 and 2 will be 4. So can I write like this? K q dash by 4 divided by r square by 4. 4 gets cancelled. Therefore, f dash is equal to k q dash by r square. Look at that. From equation number 1, can we write this particular case is what? If we give this as equation number 1 instead of this, look at that. This is a q dash by r square is actually f. So from equation 1, k q dash by r square is equal to f. So here f dash will become f. What is the conclusion, or I can say what is the result of this problem? The result of the problem is the repulsive force will be the same as previous. Okay, so hope you understand this. Example is very easy. You just have to assume the charge on sphere A and charge on sphere B, and then as per the given description you have to follow the problem, or I can say you have to follow the process, and at the end you will have the answer. So if you understand and if you like my teaching method, please do subscribe the channel, share this video to your friends in your group. If you have any doubt, you can write me in comment. I will surely reply. And now we will meet in next lecture with a new example. Till then, be safe, be focused, and do your study.